Hey, my name is Hannah Desta, and here I'll be presenting the Charged Tape Lab, Physics 2. So the purpose of this experiment is to analyze charged tape pieces and note how they interact, as well as determine how much excess charge is on one piece of charged clear tape. For a brief preview of the results of the experiment, the tapes repelled each other after getting close, as expected, and I was able to calculate the charge on each tape. Some assumptions to be made for this experiment are to treat the tape as though it were a point charge with all the charge concentrated at the center of the long tape, and assume that each U-tape made has the same amount of charge evenly distributed along the length of the tape. Without these, it would be very difficult to accurately determine the charge of each tape. The first fundamental principle that is vital for this experiment is the electric field equation, which states that the electric field is equal to K times the charge divided by the magnitude of the distance squared times the distance unit vector. Additionally, we use the electric force formula, which has the force equals the charge of the particle times the electric field. Lastly, there is the gravitational force, which is equal to the negative of mass times gravity. All of these formulas were vital for determining what the charge of the tapes are. So, in this experiment, my system was one charged piece of tape attached to two walls, which in my case was two water bottles, and an additional charged tape that would be lifted towards the other one. There's also a ruler used for measuring the distance. The surroundings included just the Earth. For initial conditions, the length of each tape was 0.3 meters and their masses were both 0.3 grams. For this experiment, we first determined if the charged tape was positive or negative by putting it near a negatively charged plastic pen. Because the tape was attracted to the pen, it could be determined that the tape was positively charged. After putting one tape under the other and slowly moving the bottom one up, the distance at which the top tape moved was found to be 2 millimeters. The gravitational force was calculated to be 2.94 times 10 to the negative 3 newtons, and the electric force is just negative of this. In my code, I first wrote in all of the relevant constants for the experiment, which included K, the charge of an electron, the charge of a proton, the length of the tape, its mass, gravity, and the distance at which the tape moves. Then, I calculated the charge of each tape given those values and created a computational model for them. From this, you can see that the charge of each tape was determined to be 1.14 times 10 to the 10 coulombs, and you can see that they obviously repel each other. There are some possible errors for this experiment that I would like to go over. For human errors, I could have measured the distance at which the tape rose incorrectly, and the charged tape could have been made with unequal charges. For computer errors, I could have incorrectly created the computational models on GlowScript. The what if question was, what if electrons had positive charge and protons had negative charge? What would change with the observations you made of your tapes and other charged objects? The answer to this is that the observations I made with the tape and other charged objects would not change, as the protons and electrons would still have opposite charges. The other quick discussion question was, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Well, interactions with your hands or other objects result in some of the charge on the tape leaving it, which leads to a weaker charge on the tape overall. This is why we want to be careful when we're handling charged tapes. So, in this lab, I analyzed charged pieces and noted how they interacted, and determined how much excess charge is on one piece of charged clear tape. This experiment overall led to a lot of interesting information that shows anyone that looks at it a little bit more about how charges interact. Thank you.